All right, so the altitude of the isosceles triangle is 4. So that means from the apex of the triangle to the bottom, that has an altitude of 4. Well, we know that this is an isosceles triangle because this angle is congruent to this angle, which means that this side is congruent to this side. So A is equal to B. All right, if A is equal to B and this is an isosceles triangle, then this is directly over the center of the base, which means drawing a perpendicular line cuts it in half. So that would make this 2 and this 2. So we have 2 right triangles with a base of 2 and a height of 4. Well, if we take this triangle on this side, we can find A using Pythagoras' theorem, which would be 2 square plus 4 square is equal to A square. So 4 plus 16 is equal to A square. 20 is equal to A square. Unsquare both sides. This cancels. I know this is going to be square root of 4 times square root of 5 because 4 times 5 is 20. I know I can take square root of 4, turn that into 2. So 2 times the square root of 5 is the length of A. And A is equal to B, so it's also the length of B. So 2 times the square root of 5 and 2 times the square root of 5. That's going to be our solution. Okay, so the tan of C. So the tan of C, so TOA, T-O-A, so the tan of C, right? So that's opposite over adjacent. So opposite, this is the opposite, and this is the hypotenuse, and this is the adjacent. So the opposite over the adjacent, that's going to be 8 over 6. The tan of C is going to be equal to 8 divided by 6 is 1.33. And this repeats. This is the tan of C. We were not asked to find the angle. We were asked to find the tan of C. And that's what we did, 1.33. All right, so you don't have to worry about the bar over the top here. I went and looked at the answers. They're not doing the bar over the top because it doesn't round, so it would just be 1.33. We can't round that at all. So it's so ka toa, right? So that is, this is the opposite. This is the hypotenuse. This is the adjacent. All right, so it's the adjacent over the hypotenuse. So the adjacent is 7. Hypotenuse is 9.2. The cosine of B is equal to 7 divided by 9.2. Round that to 2 decimal places, it's going to be 0.76. So that's opposite. So the opposite is the hypotenuse. So this is the adjacent. So the opposite over the hypotenuse, it's 5 over 7.6. So we just divide it. 5 divided by 7.6. Round that to 2 places, the sine of A is equal to 0.66. All right, let's, we got to factor something. We got to factor this one. This is a perfect square. It's a little bit tricky because it's a -1, but this is a difference of perfect squares because 1 times 1 is 1, right? So we've got 3 over x plus 1 minus 2 over x squared times x plus 1 plus 3x plus 2 over x plus 1 times x minus 1 when we factor that. So that's the trick to it, is recognizing this is a perfect, the difference of perfect squares. So now we can see that our common denominator is going to be equal to, I have no idea why I wrote x plus 3. That should be x plus 1. is going to be x squared times x plus 1 times x minus 1. So we're going to multiply each of these by what they're missing. So this is going to be x squared times x minus 1 times 3, x squared times x minus 1 times x plus 1, minus, this has got the other two, it doesn't have, x minus 1 over x minus 1 times 2 times x squared times x plus 1. And then this one just needs to see x squared. So you've got x squared times 3x plus 2 over x squared, x plus 1, x minus 1. All right, so now we're going to do a little bit of multiplication. So we'd have 3 times x squared times x. 3x cubed. 3 times x squared times negative 1 being negative 3x squared. All right, and then this is going to be 2 times, so it's going to be minus 2 times x is 2x, and 2 times negative 1 is negative 2, plus x squared times 3x is 3x cubed, and x squared times 2 is a positive 2x squared. So there's all of our little groups. All of that is going to be over x squared times x plus 1 times x minus 1. Okay, so now we're going to take the operations and apply them to each group. So that's going to be 3x cubed minus 3x squared. Negative 1 times 2x is a negative 2x, times negative 2 is a positive 2. Then this is a positive, so it doesn't change anything in here. Now all we have to do is combine our like terms. This keeps the same denominator. So we've got 3x cubed and 3x cubed. So that gives us 6x cubed. Then we have a negative 3 and a positive 2x squared. That gives us a minus x squared. And then we have minus 2x plus 2. And that's going to be x squared times x plus 1 times x minus 1. That is our solution. Okay, so we're going to simplify this one. So before we start distributing 3 times square root of 2, we're going to simplify what's inside of here. So this is 3 times square root of 2, and this is going to be 5 times square root of 4 times square root of 3 minus the square root of 2. This can become a 2. So what we really have is 3 times the square root of 2, 5 times 2 is 10 times the square root of 3 minus the square root of 2. Now that this is simplified, now we can distribute, okay? 3 times 10, that's 30. 2 times 3, that's square root of 6. And then we have 3 times a negative 1. That's going to be a negative 3. And then we have square root of 2 times square root of 2. That becomes 2. So we have 30 times the square root of 6 minus 6. All right, we want to solve for A, B, and C. So the first thing I'm going to do is I'm going to draw the little triangle. This is 4. This is 7 over 2. This is a right triangle, and this is A. And I'm going to just adjust this one. Four plus 2, that's going to be 6. And this is going to be A plus C. All right, so what we see here is we have a base that is the same. We have numbers that we can either use a scale factor or we can use a proportion. So what I'm going to do is I'm just going to write the base, and we're going to call this triangle the left triangle and the right triangle. All right, so the left triangle over the right triangle. For the base, we have 4 over 6. For the height, we have the little triangle, 7 over 2 over B. And then for the hypotenuse, the little triangle, we have A, or the one on the left, and then we have A plus C on the right. So what we need to do is we need to figure out, first of all, we could probably do this pretty easily. Let's do that one. Let's do 4 over 6 is equal to 7 over 2 over B. So that's 4B is equal to 6 times 7 is 42 divided by 2. That's going to be 21. So 21. Divide both sides by 4. B is equal to 21 over 4. That's the solution for B. So we could write that up here, 21 over 4. Okay, now we can find A pretty easily by doing Pythagoras theorem. So 4 squared plus 7 over 2 squared is equal to A squared. So 16 plus 49 over 4 is equal to A squared. Well, we need to make this to where it has a denominator of 4. So 64 plus 49 over 4. So that's going to be 113 over 4 is equal to A squared. Unsquare both sides, and we get square root of 113, and the square root of 4 is 2, and then this becomes A. So now we know what A is. We can come back in and we can write that in for A. 113 over 2 square root of 113 over 2. So now all we have to do is do our proportion. And we're going to cross multiply. So we've got 4 times the square root of 113 over 2 plus 4c is equal to 6 times the square root of 113 over 2. Well, I can divide 4 by 2 and get 2 times the square root of 113 plus 4c. And then 6 divided by 2 is 3 times square root of 113 divided by 2. Oh, I'm sorry, I've already divided by 2. Hello, this goes away. All right, so the division by 2 is done. So I'm going to subtract this from both sides. This cancels. I have 4c is equal to the square root of 113. 1 times the square root of 113. So now I'm just going to divide both sides by 4. C is equal to the square root of 113 divided by 4. And that's going to be your solution. And we know that this is correct as a positive because it's a length. And this one was square root of 113 over 2. The next problem, we're converting 4 foot cubed into inches cubed. So remember that we said this means there's 3 of these, right? We're treating this like a variable. So this is really just 4 times feet once, feet twice, feet 3 times, right? I don't need the exponent, do I? So we understand that this is going to have to be canceled 3 times. So to eliminate that, we can do a shortcut, and I'm going to show you the shortcut below. 4 foot cubed over 1. This is the long way, this is the short way. We want to go to inches cubed, so what I would do is I would say 12 inches over 1 foot, and that would cancel one of the feet. 12 inches over 1 foot, that would cancel another one of the feet. 12 inches over 1 foot, that would cancel another one of the feet. And I would have 4 times 12, 1, 2, 3, 3 times, and inches, 1, 2, 3, 3 times. That is the right answer. But the faster way to get there is to just cube everything. So 12 cubed, inches cubed, over 1 cubed, foot cubed, because it's the same thing. This is the same thing as all 3 of these. By cubing everything here, we're saying, I'm going to write this 3 times, 1, 2, 3. I'm going to write this 3 times, 1, 2, 3. I'm going to write this 3 times, 1, 2, 3. And I'm going to write this 3 times, 1, 2, 3. So then we can just go straight to our answer. This cancels this. And we have 4 times 12 cubed inches cubed. It's the same exact answer, but it takes up less paper and it's less writing. All right, here we want to find the tan of E. So remember what we've done before. Tan of E, that's TOA. So opposite over the adjacent. So the tan of E is equal to the opposite over the adjacent, because this is the hypotenuse. So 8.73 divided by 11.30. The tan of E is equal to 8.73 divided by 11.3. I'm going to round that to 2 places, 0.77. Typically, we round to 2 places by default. Don't let that throw you for a loop. So that would be your answer. Let's look at the next one. All right, we're going to find the cosine of D. So the cosine of D, that's ca, so that's adjacent A over H over hypotenuse. CAH, ca. So the cosine of D is going to be, you've got the opposite here, and this has to be the adjacent side, and this is the hypotenuse. So it's going to be adjacent over hypotenuse, so 3.63 divided by 4.76. So the cosine of D is going to be equal to 3.63 divided by 4.76. So that's going to be 0.76. I bet by now you have figured out how to solve these problems. We're going to do this one anyway. The sine of C. So sine, that's so it's opposite, which would be 3.61, over hypotenuse, which is 7.52. So the sine of C is equal to 3.61 divided by 7.52, 0.48. All right, for this one, it's pretty straightforward. We can do all of it on the calculator. So we've got 6 times the sine of 37.42 degrees. So let's get our big calculator out. So we're going to put in 37.42 degrees, and we're going to ask for the sine of that. Okay, now we've got this number. We're going to multiply that by 6, so times 6. We're going to round that to 2 places, so it's going to be 3.65. So 3.65 is the solution to this. Okay, so we are going to find the equation of line A and the equation of line B. So we can see that A is crossing the positive 2 on the y-axis. So it doesn't matter what the value of x is, y is always going to be equal to positive 2. So that is going to be what you put, not this. You're going to say y is equal to 2. Okay, this part, this y is equal, is very important because it says to find the equation of the line. So you have to write a statement with the equal sign in it that tells the equation of the line, not just its y coordinate. Okay, all right, so let's look at B. So we have 2 points here. We have a point crossing the y-axis at the -4, and we have a point that is at 4, -3. So what I'm going to do is I'm going to write this is y is equal to mx plus b. That is the linear equation. My plus b is going to be this point where it crosses the y-axis. That's -4. The x comes down, the y comes down, the equal sign comes down. M is the slope. So I'm going to count my slope. So I've got from this point to this point, you have to go vertically and then horizontally. So I'm going to count my spaces. 1, 2, so 2 spaces up. So that's toward the positive side. So it's going to be positive 2 over 1, 2, 3, 4. Okay, so 2 over 4, you want to reduce that. Y is equal to 1 over 2x minus 4. That is your equation for line B. And that's what you would write right here. Y is equal to 1/2 x minus 4. All right, so we can find, let's see, x using 31 degrees. Well, first of all, let's find B. If this is 31, remember we've got these triangles called 60, 30, 90 triangles. So if this is 31, this is 1 less than 60. So B is equal to 59 degrees. So that's the first one, 59 degrees, right there. All right, so now that we have B, we can find X and M. So if I want to find the adjacent side to 31 degrees, that would be M. So adjacent, that's going to be cosine. So the cosine of 31 degrees is equal to adjacent over the hypotenuse. And the hypotenuse is 14. Okay, so that's going to be 14 times the cosine of 31 degrees is going to be the value of M. I just multiplied both sides by 14. So I get my calculator, I get the big one, and I perform this calculation. 31 cosine times 14. So 12.00 is the value of M. Okay, so I can do something very similar to find X for 59 degrees. I can say the cosine of 59 degrees is equal to X, because this is the adjacent side, over 14, because this is the hypotenuse. So I'm going to say that 14 times the cosine of 59 degrees is equal to X, because I multiplied both sides by 14. So if I clear this and I say 59 cosine times 14, I get that 7.21 is the length of side X. All right, this figure is the base of a cone. That's going to be crucial later. And it's 4 feet tall. we're going to find the volume of the cone. First, we have to find the formula for volume. The formula for volume is volume of a cone. You have the area of the base times the height. But for a cone or a pyramid, we divide that by 3. So first we need to find the area of the base. So I've got a half circle here. So for a circle divided by 2, or cut in half, we're going to take the area of a circle and divide that by 2. So that's going to be pi times 4 feet times 4 feet. Divide that by 2. 4 times 4 is 16. Divided by 2 is 8. So 8 pi feet squared is this section here, right? And so here I've got a big triangle. If this is a radius of 2, then this is a radius of 2, and this is a radius of 2. So we've got 6, 8, 10, 12. So this is a base of 12, and the diameter of the circle is 2 times the radius, so it's going to be 8. So 12 by 8, area of a triangle, 12 feet by 8 feet, and divide that by 2. That's going to be 48 feet square with all of it. But we have to get rid of this section right here because it's not a part of it, right? So let's do that. So this little half circle, we've got pi times 2 feet times 2 feet divided by 2 because it's a half of a circle, and we're going to subtract that. So minus 2 pi feet square. We can't really take that away from this, but we can take it away from this. So we're going to subtract that. Minus 2 pi feet gives us 6 pi feet. So we've got an area of the base, volume of the cone, is going to be 48 plus 6 pi feet squared, right? Because this was the area and this was the area. This was the area we took away from this because those are like terms. Now we're going to multiply that times the height, and the height is 4 feet. And that was given to us right here. And then we divide that by 3. All right, so we're going to multiply 4 times all of these things in here. 4 times 48. Can't do that in my head. I'm not sure. No, this could be, oh goodness. I can't think. 48 times 4, 192. Okay. 192 plus 4 times 6 is 24. Pi. All right, now all of this is feet cubed because we had feet twice, feet a third time, and we're going to divide that by 3. So 192 divided by 3 is 64, and 24 divided by 3, that's 8 pi feet cubed. This is your answer. And that would be your solution to the volume of the cone. 64 plus 8 pi feet cubed. All right, let's look at the next problem. All right, so we are going to use our functions to find b, h, and y. All right, so b, again, we know this is 90, this is 28, so this has to be 62 degrees. So that one was easy, because we know the 3 added together is going to equal 180 degrees. Right, so that one was easy peasy. But now we can use that to find h and y. So let's look for h first so we have a hypotenuse to use for the other one. So we've got the sine. Let's do the cosine. The cosine of 28 degrees is equal to the adjacent. This is the adjacent for 28. So 9.5. And the hypotenuse is h. So we multiply both sides by h. All right, we don't have a value for h, but we do have a value for this, so we're going to divide both sides by that. So h is going to be equal to 9.5 divided by the cosine of 28 degrees. So the way I would put that in my calculator would be with parentheses. I would say 9.5 divided by parenthesis 28 cosine parenthesis equals. So h is equal to 10.76 because we're rounding it to two places because that's what we do. So that's what h is. H is 10.76. So now we can find y. So for y, I'm going to scoot this over a little bit. I'm going to use cosine of b, which is 62 degrees, is equal to, now this becomes y is adjacent to b. So I'm going to say adjacent over hypotenuse. I'm going to multiply both sides by the denominator. So 10.76 times the cosine of 62 is equal to y. So I'm just going to do that on the calculator. 62 cosine times 10.76 is 5.05 is the value of y. Okay, so this one is a little bit of a trick problem. The measure of angle BAD, so that would be B, hang on, I didn't get the right marker. BAD, that's this marker right here. Angle A, right, from here to here, that is K. We know that two consecutive angles in a parallelogram equals 180 degrees. So the measure of angle BAD plus the measure of angle, if you look here, ABC, that's the other side, that has to equal 180 degrees. It says the measure of angle BAD is K. So all we can do is take K from both sides. So the measure of angle ABC is 180 minus K. That's what you're going to put in here. 180 minus K. It's that easy. There's no way you can find a solution to that. You're not getting enough information. So that is the answer to that first blank, 180 minus K. All right, so let's erase these little marks. I'm going to leave that up there. Okay, so the other thing you have to remember is that the diagonals in a parallelogram bisect each other. So this one is equal to this one, and this one is equal to this one. So that means 4x plus y is equal to 6, and 4x plus 2y is equal to 8. So what I'm going to do is I am going to multiply this one by a -1, and I'm going to put it right down here. So negative 4x minus y is equal to -6. Then I can cancel. 2 minus 1y is y. 8 minus 6 is 2. So y is equal to 2. Now all I have to do is go back over here. 4x plus 2 is equal to 6. Subtract 2 from both sides. This cancels. 4x is equal to 4. Divide both sides by 4. X is equal to 1. And that's your solution. Not so hard. Next problem. All right, we're going to use trig functions to find x, y, and p. So we have absolutely no idea what x and y's degree of measure is, but we have the base and we have the height. So we can use Pythagoras' theorem. 8 squared plus 12 squared is equal to p squared because p is the hypotenuse. 64 plus 144 is equal to p squared. That's going to be 208 is equal to p squared. Square root of 208 is equal to p. We know it's positive because it's a length. So we just need to find the square root, or we need to factor something here. So I know that that's going to be 2 times 104, which is 2 times 52, which is 2 times 26, which is 2 times 13. So 2 times 2, that's going to be 2, times 2, times, I can't do anything with that, so it stays square root of 13. That's going to be the value of p. So 4 times the square root of 13 is the value of p. Okay, now we can solve something with that. So we are going to use, let's use cosine. So the cosine of, let's find y. The cosine of y is equal to, that's going to be adjacent over hypotenuse. So this is now 4 times square root of 13. So adjacent over hypotenuse. So 12 over 4 times the square root of 13. So that is going to be, let's see, 12 divided by parenthesis 13 square root times 4 parenthesis. So that's 0.83205, so it'd be 0.83. Now we're going to find the inverse of that, cosine, 33.69. That's our y, 33.69 degrees. So that means x just has to be subtracted. 90 minus 33.69 is 56.31 degrees. So that would be our x, 56.31 degrees and 33.69 degrees. And that's our solution. All right, we're going to find c in this problem. So first of all, a over c plus d equals x over m. So we need to find a common denominator, and that's going to be mc or cm. So I need to multiply, so it'd be m over m times A over C plus CM over CM times D over 1 is equal to C over C times X over M. So that gives me AM over CM plus DCM over CM and X, or CX I should say, over CM. Multiply all of that by the CM. Cancel, cancel, cancel. AM plus DCM is equal to CX. Subtract DCM from both sides. AM is equal to CX minus DCM. Factor out the C. AM is equal to C times X minus DM. Divide both sides by X minus DM. So AM over X minus DM is equal to C. So that's what you'd put up here. AM X minus DM. That's your solution. All right, so here we're going to find H and Y. So let's see. We're going to use the cosine of 21 degrees is equal to 6.4 over H. Because when we're talking about this angle, this is the adjacent, and of course this is always the hypotenuse. So Ka is adjacent over hypotenuse. So we're going to multiply both sides by H. That gives me H times the cosine of 21 degrees is equal to 6.4. Divide both sides by the cosine. H is equal to 6.4 divided by the cosine of 21 degrees. So calculator time it is. We have 6.4 divided by, parenthesis, 21 cosine, parenthesis, equals 6.85. So the hypotenuse is, actually we round that to 6.86. Okay. So now we have a couple of choices. We can choose to use Pythagoras' theorem, or we can use, since we know this is 21, this is going to be 69 degrees. So we can either use cosine of 69 to find y, or we can use Pythagoras' theorem. Let's do both. Let's just see what we got. So we've got 6.4 squared plus y squared is equal to 6.86 squared. All right, that's a lot of decimals. 6.4 times 6.4. 40.96 plus y squared. And then we've got 6.86 times 6.86. 47.06. Close enough. I'm going to subtract this from both sides. So 40.96 minus, 47.06 minus 40.96. Y squared is equal to 6.1. Unsquare. Y is equal to the square root of 6.1. And if we want to, we can look at that. What is that? It's going to be 2.47. So y is equal to 2.47. Okay, so let's try it the other way. So we're going to use, this will be the adjacent side to 69, and this is the hypotenuse. All right, so the cosine of 21 degrees is equal to, we're looking for y, so y over 6.86. So 6.86 times the cosine of 20, I'm sorry, not 21 degrees. I just caught that. We're talking about this angle. So it's 69 degrees and 69 degrees. My mistake. I'm so sorry. But that will give us the value of y, because y is the adjacent to 69 and 6.4 was the adjacent to 21. So I have to switch that angle around. Okay, so now we can just do that on the calculator. So I've got 69 cosine times 6.86. If I round this, I get 2.46. Really, really, really close. We got 2.47 here and 2.46 here. And I have a feeling if I had not rounded this, then we would be perfect. Let me unround it just for funsies. Let's go back and undo that. We know this is 40.96. So let's unround it. Let's do 6.86 times 6.86. So 47.0596 minus 40.96. All right, so y squared is equal to 6.0996. Find the square root of that. There we go. It's still 2.47. Y is equal to 2.47 if we round it. And if we round this one, it's 2.46. So really, really close. Really, really close. So I'll have to go back and make sure that I have both this answer and this answer in as possible results. I'm not sure what Saxon had for their answer key. But if you got either one of these, I'm going to mark it right. Okay. If you didn't attempt it, it is what it is. But I'm going to go back and put both of those as acceptable answers. All right, more trig functions. We're going to find b, we're going to find a, and we're going to find x. I feel like that we could find x really easy. So let's just use Pythagoras theorem. X squared plus 4 squared equals 7 squared. X squared plus 16 is equal to 49. X squared is equal to 33. X is equal to the square root of 33. And we need to have that as an actual number. So I'm going to put that in here. So 33 square root. All right, I am not going to round this at all. 5.744563. Okay, so that is the value of x. I am going to assume that this probably wants the square root of 33, but I'll check that. You probably could also put in 5.74 and get the same. Either one of these is probably correct. And because we're in Algebra 2, this one is probably the one that is in the system. I will double check. All right, so now that we have that, let's see what we need to do to find A and B. We really just need to find one of them. So here's the deal. I really don't want to use this number when I do my calculations. I'd rather use this whole number 4. So let's do Yeah, let's do this. The cosine of a degrees is equal to the adjacent over the hypotenuse, because we have some nice whole numbers to use instead of doing b, because if we did b, we would have to use this one of these, which would be crazy, right? So now I can just say 7, or I can just divide this and use my inverse key, and it'll tell me. So we're going to say 4 divided by 7 equals, okay, it equals that. That's my cosine. I'm going to use my inverse cosine, and it's going to tell me that's 55.15. So A is equal to 55.15 degrees. 90 minus 55.15 is 34.85. So there's that. All right, I'm going to go and check and see which one of these actually is looking for. Okay, so good news is I already had both of these in as possible answers, and both of these were correct. So it makes sense that you would want to use the whole numbers to find A to then find B, because this is kind of hinky over here. But the values that we're looking for are these. It's this one or this one. Doesn't matter which way you figured it out. It will take it. All right, so let's, and also on this one, both of these were already in there to take either one of those. So that is nice. Okay, so let's look at the next problem. All right, so first of all, we've got to get everything on one side. So we're going to add, same concept we've always used. I'm going to add it to both sides. So this is going to be x cubed plus 12x squared plus 20x is equal to 0. Now we know that we need this to be x squared, so we're going to take an x out. That leaves x squared plus 12x plus 20. Right? We divided each one of these by an x, and this is what remained. So now we can factor this. We've got, or we're going to try to factor it. So we've got x, and let's see, 20 is 2 times 10 or 4 times 5. So to get 12, it needs to be a positive 2 and a positive 10, because 2x and 10x gives us 12x. So that's how we would solve that. So x is equal to 0. X plus 2 is equal to 0. X plus 10 is equal to 0. So x could be equal to 0. If I subtract 2 from both sides, negative 2. If I subtract 10 from both sides, negative 10. Those are the 3 possible solutions for x. 0, negative 2, negative 10. All right, so we're going to start by getting the same base. This is going to be 5 squared. And then we have that other 5 in there. Now that the bases are the same, now we can go about our merry way with finding the innermost. So the innermost is written in a square root, and that's the fraction exponent for square root, because the index is here. It's written one time with the index. Now we've got this base with an exponent of 2 written one time with an index of 3. Now we multiply. 1/3 times 2 is 5 2/3. And 1/3 times 1/2 is 5 1/6. we need to have a common denominator. So I'm going to multiply this fractional exponent by 2 over 2. So that's going to be 5 and 4 over 6 times 5 and 1 over 6. We know we add these together. So that's going to equal 5 and 5 over 6. That's going to be your solution right there. Okay, this is one that everybody kind of struggled with. This is a logic problem, right? There is no hard math in here at all. It just looks hard. We start with the measure of angle JAC. You got to find JAC. That's right here. JAC is 150. Okay, so we know that this is going to be a 180 degree because it's a straight line. So that means if this is 150, then this has to be 30. So x is equal to 30 degrees. Now, if x is 30, and we know this is 90, then y has to be 60. If y is 60, we know z is 60 because it's a vertical angle. These two are going to be the same. So this one is 60. If this is 60, then s is going to be 30 because 60 and 30 are 90 right there. That's the 60, 30, 90 triangle. So this is going to be 30 degrees. Now, if you look at the bigger picture, you've got a big triangle right here, right? This one doesn't matter anymore. Z doesn't matter. But this right here, this perpendicular, tells me that this is perpendicular also. So this is 90 degrees, and this one's 30 degrees, so that means P is 60 degrees. And if P is 60 degrees, right, we've got vertical angles here. So this one has to be 60, and if this is 60 and this is 90, then this is 30. So you can see we didn't even have to do any math, not really. We went from 30 to 60 to 60 to 30 to 60 to 30, just looking at the angles and finding our right triangles in there. That's all we did. Let's look at the next problem. Okay, this next problem you got correct, except for the fact that feet does not have a period on it. So when you put that period in there, that's what got it wrong. Everything else is correct. All right, we're going to solve this, and we're going to do that by unsquaring. So x minus 3 is equal to plus or minus the square root of 5. Add 3 to both sides. X is equal to 3 plus or minus the square root of 5. That's it. Again, I am seeing that you're putting the period on feet. Feet does not get a period. Let's move on. All right, this one says to find x. There it is. Okay, that's not funny, Miss Tracy. All right, so we're going to find x. If this is 19 degrees and this is 90 degrees, then we know that this has to be 71 degrees. So now we have our interior angles all labeled. So we should be able to find some values. Excuse me. So if I want to use the cosine of 71 degrees, that would be the adjacent x over the hypotenuse of 7, which would really be 7 times the cosine of 71 degrees is the value of x. Because that would be the other side with the hypotenuse that's making the 71 degree angle. And if I want to find y, I would do the same thing, but I would do 19 degrees because the adjacent side is y. So we can actually skip this step and just say the hypotenuse times the cosine of 19 is going to give us the value of y. just like we did for this, and then we skipped over, we can just skip that first step altogether and go straight to the calculator. So we're going to say, let me put that over here like this, 71 cosine times 7, round it to two places, would be 2.28. So 2.28 is the length of x. All right, so now we've got two radicals times each other with variables and exponents. So we're going to take what's on the inside here, x squared, y. We put it in parentheses. This is written underneath this radical one time, and this radical, because it doesn't have a number here, that number is 2. It's a square root. When there's no number, the number is 2. And that's times this one. So we're going to do the same thing. We're going to put what's in here in the parentheses. That is written one time, and it has an index of 3. Now we're going to multiply. 1/2 times 2, that's x, and 2 over 2. 1/2 times y to the 1, that's y to the 1/2. 1/3 times y squared, that's going to be y 2 over 3. And x to the 1 times 1/3 is going to be x to the 1/3. So we're going to rearrange these and put these next to each other. So we've got x 2 over 2 and x 1 over 3. We've got y 1 over 2 and y 2 over 3. Common denominator is going to be 6. So I'm going to multiply this one by 3 over 3 and this one by 2 over 2. So that gives me x 6 over 6, x 2 over 6, which gives me x 8 over 6, right? So this one, I'm going to do the same thing, times 3 over 3 times 2 over 2. So that gives me y 3 over 6 and y 4 over 6, which gives me y 7 over 6. Now, I can't combine these because the bases are different, but I can reduce the fraction. So I've got x 4 over 3, y, this can't reduce, 7 over 6. That is your solution. All right, 85 miles per second, 2 miles per hour. So we've got 85 miles per 1 second. All right, we don't need to convert miles. Miles stays the same. All we need to convert is seconds to hours. So we're going to say there are 60 seconds in 1 minute, cancel the seconds, and there are 60 minutes in 1 hour, cancels the minutes. So that is going to be 85 times 60 squared, and that is going to be miles. Actually, I think it might be written mph. If it is not written like that, it's going to be 85 times 60 squared, mi, 1 hour. Or possibly just, actually I know what it would be. It's going to be mi over hr. Let me double check that. All right, that looks like the last one, but that is the correct way to do it right here. Miles over hour, which is the same thing as miles per hour, and we're used to seeing miles per hour like this, but we've been learning it like this. We haven't converted anything else to the acronym, so we're going to keep it the same as all the other, keep the format the same.